Alright, in this video we're going to learn about special types of linear systems. Up to now you've learned how to use two equations and either graph and check them to find a solution. You've been able to do linear combinations or substitution. And you found out that we've been working in this area right here. One solution, because that's where they're going to cross. And today we're going to learn about some other types of linear systems. For instance, in this one here, we're going to learn that it's possible that the two equations actually never meet. They're going to be parallel forever. And in that case, there is no solution because there's, right here, in this one there was a solution. They met together. That meant that point worked both for two equations. It worked for both of them. But there is not a point for when the lines are parallel, so there will be no solution in this case. The other possibility is this guy over here, and I've tried to make this line a lot thicker to show you that whether there's 2, 3, 10, however many equations are in the system, every single one of those are identical. So they all land on that graph right there, on that line. In that case, it's infinitely many solutions, and the lines coincide. When one line piles on top of another one, it's coinciding with the other one. So let's take a look at an example where we're going to identify how many solutions are in this equation. System. I've got one equation here, 2x plus y equals 4, and another equation, equation number 2, 4x minus 2y equals 0. Looking at this, I could graph and check it, I could use substitution, or I could use linear combinations to find my x and y right there. I decided on this one right here because I like the y's by itself almost, to just go ahead and use substitution. So I'm going to go ahead and take the first equation and turn it into y equals mx plus b, slope-intercept form. Substitute this into the y right here. So for step 2, I'm going to write equation 2 with the negative 2x plus 4 that I found out. When I plug it in, I've got 4x comes down. I've got distributive property happening right here. Negative 2 times negative 2x is a positive 4x. Negative 2 times positive 4 is a negative 8. Combine like terms right here. My next line will be 8x minus 8 equals 0. And then I went ahead and inverse operated negative 8. Got him on the other side. So he's now positive 8. And divide this out. And I get x equals 1. So now out of my solution I'm looking for. So far I'm halfway. I got 1 for x. Remember, I take the x and I substitute that into the revised equation, which is this one right here that I revised in the slope-intercept form. So I take that equation, put the 1 in, and I work it out, and I find out that y is 2. So now I have my whole thing. I have x is 1 and y is 2. I'm going to verify that the solution 1, 2 actually does work. And I'm going to just plug them back into the original equations there. And when I plug them in, I do find out that 4 is 4 here, and 0 is 0 over here, and that the answer is one solution, and the solution is 1, 2, x and y, but it is one solution. So the question, or the answer to identify the number of solutions of this linear system right here is 1. One solution works. They cross at coordinate 1, 2. Positive 1, positive 2. Example number 2. Identify, again, how many solutions are there going to be. So, my new system, x minus 2y equals 5. Negative 2x plus 4y equals 2. I'm going to go ahead and I'm looking at that and I'm just thinking how, how I can, where do I want to start? Should I just graph and check it? Can I do substitution? Or can I do linear combinations of some sort? Well, I'm looking at these here, these x's, there's only difference is a -2. The difference here is kind of they're kind of the same. And these are really off. And I'm just trying to figure out, could I do some kind of multiplication to this one so it gets closer to equation 2? And so I'm going to multiply by 2, the top one. This is the way I want to go. I want to do a linear combination here first. I multiply by 2. I get 2 times x is 2x. 2 times a -2y, -4y. And 2 times 5 is going to give me the 10. I bring the second equation over, and you can see what happens. Now I have my, if you remember, when I want to either, through linear combinations, I want to look for identical variable, identical coefficient that have opposite signs. I have that now, a positive and negative, a 2, 2, that equals 0. Negative, positive, that also equals 0. And then I just add this up and I get 12. 0 equals 12. That is a false statement. And because we decided to kind of shortcut it and multiply it by 2 here, we found that out very quickly. The answer to this is because of the resulting statement 0 equals 12 is false, therefore the linear system has no solution. That means if there was no solution, that means the lines are going to be parallel. Lines must therefore be parallel. Let's just see. How do we know if a line's parallel? It's because the slope is going to be the same for each equation. So I'm going to put both of them in slope-intercept form. And when I do that, I find out that number 1, way down here, y equals 1/2 x minus 5/2. When I took the second one and I converted it into slope-intercept form, I got y equals 1/2 x plus 1/2. I'm looking at the slopes here. That's what I'm very interested in. And I see that they are the same, in fact. The slopes are equal. When I have the same slope, I have parallel lines. They never cross. And we have a no solution situation here for this particular linear system. Okay, example 3. Identify the number of solutions. Equation number 1, 3x plus y equals -1. Negative 9x minus 3y equals 3. And again, I'm looking at these and I've noticed, here's the 3 is a factor of 9, 1 is a factor of 3, 1 is a factor of 3. And I'm trying to think of combinations that will make these guys be a little more related to each other. And I decide I'm going to take this one and multiply it times a -3. Some of you might have thought I might do just a +3, but I'm going to do a -3, and let's see what happens. -3 times 3x, -9x. Notice I got the same right there. -3 times the positive y gives me a -3y. And again, I got the same thing. And the last part, -1 times -3 gives me a +3. I got the same thing there. So when I bring this over, interesting enough, they are identical. They do not look the same in the beginning, but by doing a simple multiply by everything by -3, you'll see that they become identical lines. And because of that, they're identical equations. Because of that, the answer is going to be these lines coincide. Means they're going to be right on top of each other. And it has infinitely many solutions. Any solution for this particular equation, which is -9x minus 3y equals 3, is also a solution for the system. Both equations have infinitely many solutions. Let's do another one. Number 4. Identify the number of solutions if I have x plus y is 3 and I have 2x plus 2y equals 4. My first choice, just by looking at that, I want to multiply the top one by -2 because I'm trying to think of things that, remember, I like to get opposites. I like to get the opposites, positives and negatives, and see if I can make something work. So I am going to do that. I'm going to multiply this by -2. And when I do that, -2 times x is -2x. -2 times that is -2y. And the 3 would be -6. So I'll have a -2x minus 2y equals -6. I bring down the second equation here. And we have a similar situation a couple problems ago, where these actually canceled out, and it left me with -6 plus 4, which is -2. 0 equals -2, no solution. It's false statement. That means there is no solution, so that means the lines, again, this particular system is parallel. They have parallel lines. But let's say if you have a hard time taking a look, and I can go multiplying everything by -2 to work that out quickly, it's okay. You can use another method. You can use substitution. And so why don't we just find out what x equals here? I would move the y over through inverse operations. So x equals -y plus 3, and I can substitute that into this equation. So 2, substitute it, -y plus 3 goes in there, plus a 2y equals 4. Distributive property right here, 2 times -y, -2y, 2 times +3, +6, and bring the 2y down for equals 4. Notice I got a +2y and a -2y here. I'm going to take these guys, combine like terms, bring them together. They cancel out, leaving me with a 6 equals 4. Obviously, that does not work. That's also a false statement. That, on the first side, that was a false statement. So is this. Let's say that some of you feel that, well, why don't I put the 6 on the other side to really find out what happens? Go ahead and -6 here, -6 here, and you find out that I actually ended up with the same thing. 0 equals -2, 0 equals -2, and we still have no solution there. So the number of solutions for this particular system is no solution and parallel lines, which means the slopes are equal. Example 5. X plus y equals 3 and 2x plus 2y equals 6. Again, I'm looking at that and I'm thinking about some numbers what could I multiply one equation by to get me some numbers that look the same as the bottom equation here. And I can see that, x plus y equals something, x plus y equals 3, and these 2's are in there. So this one I decided to just multiply by 2, a +2. And when I do that, multiply equation 1 by 2, 2 times x is 2x. 2 times y, 2y. 2 times 3, 6. Bring down this, and you can see here, identical equations. The number of solutions for identical equations is infinitely many. So as many as you can think of. If I had difficulty trying to figure out what to multiply it by, you can always fall back on substitution. Let's just find out what x equals in the first equation here. Take x plus y equals 3, and inverse operation on the y, so x equals -y plus 3. You can take the -y plus 3, Substitute it into the second equation. Work it out. Distributive property right here. 2 times negative y is negative 2y. 2 times 3 is 6. Bring the 2y, bring the 6 down. And again, combine like terms. Combine like terms come right here. You can see those cancel out again. And I have 6 equals 6. So this time, I do have a true statement. I do have a true statement. 6 equals 6. When that happens, I also know that I have infinitely many solutions. So this is a line, remember this has that really thick line. They all land, they're all on top of each other. This is all about finding the number of solutions.